Okay, guys, so when we look at a question like this, the first thing we need to recall this rule. Okay, hopefully you've went through your exponents rule, but this thing is a to the power of m times by a to the power of n is actually equal to a to the power of m plus n. In other words, what we're saying is when the bases are the same, then it means we can do what? We can add the exponents here. We can say 2 to the power of 3x minus 1. I will add everything because remember the bases are the same and we're multiplying it, right? So that means we can add the exponents. So I have a plus x and plus 1, right? Over. At the bottom, guys, I will change that 4 into a 2 to the power of 2, right? And then I have a 2x minus 2. Now, what's going to happen is then at the top, I'm going to try and simplify everything. What do I have at the top? Okay, at the top, I have 2. Then the x's that are the like terms, right? So 3x plus x will give me 4x, right? And then negative 1 plus 1. So negative 1 plus 1 will give me 0. So that means those, they canceled each other. So we have 0 there. That's why we have 4x at the top. Now at the bottom, you have to take note of this. Very important that this 2 will multiply the 2x and then also multiply the negative 2. So I'll actually have 2 to the power of 4x and then minus 4. 2 to the power of 4x minus 4. Next. So there is a recall. We need to recall something as well. And that is if we have a to the power of m over a to the power of n, this is the same as a to the power of m minus n. So that n there actually subtracts the m, right? So that means, okay, that means we have 2 because the bases are the same. Then we'll have 4x at the top. And then now we will subtract what we have inside the brackets, which is 4x minus 4. Do you see that? That means we can simplify from there. We will have 2 to the power of 4x minus 4x plus 4. Right, and those two, they will cancel and give you a 0. So you have 2 to the power of just 4 and 16. Okay, so when we look at a problem like this, first thing, guys, that you need to be aware of is that we have a plus here and we have a minus here. Right, so now this does not allow us to do what we have done in the first question. We have to factorize here, guys, and then we can cancel, and then that way we will simplify the question. First thing, we need to change that 9 to a 3 squared. And then we'll have 3 to the power of x. This is advisable for us to separate 3 to the power of 2, then plus 5 times by 3 to the power of x over, then you have 3 to the power of x minus 3 to the power of x times by 3. Right, so we have that now. Okay, then we can just at the top, if you want, you can have 3 to the power of x times by 3 to the power of 4 plus 5 times by 3 to the power of x over 3 to the power of x minus 3 to the power of x times by 3. Now, I want you to look at something here. If you see this, guys, I have a 3 to the power of x and then a 3 to the power of x, right? I actually want to write the plus and the minus in a different color so you don't make a mistake of actually confusing those. So there is a plus here, there's a minus there, right? So as you can see on either side of the plus at the top here, there's actually a 3x and also a 3x, right? And also at the bottom, if you have noticed that at the bottom, we have a 3 to the power of x and also 3 to the power of x that we can factorize. Okay, so let's just go ahead and put everything into perspective. So we'll have 3 to the power of x, and then inside the brackets, we are going to be left with 3 to the power of 4 plus 5, right? Remember the green parts are gone now. So now we just left with the blue parts, right? So we left with that and we left with this. And then here we'll have 3 to the power of x. And then what's going to be left inside? A 1 minus just 3. Okay, so then we can just cancel those. Now we're allowed to cancel, right? And then at the top, guys, you're welcome to just use your calculator. So you're going to have -2 at the bottom, which gives you 86. So 86 divided by -2, and your answer should be 43, but -43. That is it, guys. Okay, guys, let's look at this question. With this question, as you've noticed, we have a plus there. That's a bit of a problem. So we'll have to factorize at the top surely, because we can't just start canceling when there's a plus there. That's on the way. So we'll separate the exponent there. We'll have 3 to the power of x times by 3 to the power of 1, which is just 3, plus 3 to the power of x over. Right, now the 27 can be written as 3 to the power of 3, right? So we have 3 to the power of 3 times by 3 to the power of -1 times by 3 to the power of x. Okay, so now if you look at the top, I can factorize a 3 to the power of x. I can factorize a 3 to the power of x and a 3 to the power of x, right? So I have 3 to the power of x. Inside, I'll be left with 3, then plus 1, right? Over. Now, at the bottom, I don't need to factorize anything. There is no plus there. But I am welcome to say the like terms here, right? That will give me 3 to the power of 2. Okay, if you didn't see that, this and that will give me a 2, right? Then I'll have the 3 to the power of x. Now, those two will cancel, and then I'll be left with 4 at the top and then 9 at the bottom, guys, and that is it. There's no way I can go from there. Right, and here's a tricky question, guys. I don't know if you can see this, but this is actually a difference of two squares. So we call them dots, right? But I can do something here at the top. I can actually write this. I can write it as 1 plus 20, 20, right? Here, I can open my brackets and just say 1 plus 20, 20, and then 1 minus 20, 20. Can you see that, right? And then I'll just put brackets around it. Look at what's going to happen. Right, so this will cancel with that, and then I'll be left with 1 at the top, and at the bottom, I'll just be left with 1 minus 20, 20, which is, of course, 1 over negative 20, 19. And then you can just sort it out as follows. And that's your answer for this question.